Hi, this session is on linear applications, or it's also called linear modeling. And this session is on being able to find or write an equation from given information. And there are certain steps that you need to follow to find an accurate equation. So here is a question, and it tells us that a tank holding 600 liters of water empties at a rate of 200 liters every hour. So from the information, we should be able to write an equation that relates the amount of water in the tank to how many hours have passed. Now, our first step is step one is to write a statement to identify the independent the dependent and independent variables. So let's just recap. If you've forgotten, just to recap, if we draw a quick building and there's some windows and there's the ground, to remember what variable depends on what. If the building is the y-axis and the ground is the x-axis, we know the building depends on the ground. So y depends on something. So y is dependent, or the dependent variable, and that means x is independent. It doesn't depend on anything. And so with our problem, we have to identify, okay, what is y going to be and what is x? Because we know a linear equation is in the form of y equals mx plus c. And to have an equation, we need to find m and we need to find c. Y and x, we know, represent the y-axis and the x-axis, but now that we have a real life problem, y will be something else. It could be the amount of water in the tank, or it could be how many hours have passed. So we have to make sure we know what y is and what x is in relation to our problem. So with a statement, it's simply write a sentence. The keywords in your sentence is depends on. Have that in the middle. And now what depends on what? Let's grab our problem. A tank holding, we've got 600 liters of water. So we have water in a tank. It's being emptied, and there's a rate there every hour. So we have water in a tank and hours passing. So the amount of water in the tank, does it depend on how many hours have passed? Yes, that makes sense. So we would write this. The amount of water, or you can just write water for short. So the water in the tank depends on hours. Okay, how many hours have passed? We know the more hours that pass, the less water there'll be in the tank because the tank is emptying. Now, water depends on hours, and we know y depends on x, just like our building and the ground. And so now we have identified what our variables are. So y will be water and x is hours. So now step two is to state your variables. State means to make sure it's clear to the person looking at your work what y represents and what x represents. And we know that sometimes we may not even have y and x. We may have different variables or different letters to represent our problem. So to state our variables, so our next step, one second. So step two, to state our variables, we simply do this. Y is water in the tank, and also state your units. The units we are using are liters. We can put that in brackets. And x represents how many hours have passed. Now, you can just write hours, or if you want to be, I guess, more specific, x represents time, and the units are hours. But if you write hours, that's fine. So that's step two. We have stated our variables, so we know clearly y is water, units are liters, x is time, the units are hours. Now our next step can be to identify the initial or the starting amount. Now remember, with these steps, you can actually go in any order you want, but this is the order I like to follow. So now to identify the initial or starting amount, that is given to us in the question. Let's have a look. So we've got a tank holding 600 liters of water starts to empty, okay, at a rate of 200 liters every hour. So what's our starting amount? How much water was already in the tank? Well, the answer is 600 liters. So our third step the initial or starting amount, so initial amount was 600 or 600 liters. Now, the reason why it's important that we have a starting amount is the starting amount is what C is. So in this case, C is going to be 600. A lot of the times C is 0 because we start at 0, but in this case the tank had 600 liters in the tank, so the starting amount is 600. And remember where C comes from in our equation? I'll write it up here, y equals mx plus c. Okay, we need to find m and we need to find c. We know now what y is. Y is the amount of water in the tank. X is the time or hours that have passed. And now C is simply the starting amount, 600 liters. You don't have to write the L there because it looks like another variable. So when writing the equation, don't put the L in there because it looks confusing. Now, our next step maybe is, so remember with our third step, I just added this bit in there. To identify the initial or starting amount, this is the value of C. Now, our fourth step can be now to find or calculate the gradient. And we know the gradient, we use the symbol M. Okay, now let's recap on what the gradient is. Now just to recap, we know the gradient, when it comes to straight lines and graphs, gradient is how steep a line is, or the slope. So we can have, for example, a positive gradient that's going up the hill, a negative gradient going down, so we're losing something. We can have a horizontal gradient. Sorry, that's not really horizontal. There we go. We can have a vertical gradient. And some gradients can be way steeper than others. Okay. Now, we also know to calculate the gradient, we've learned that, well, m, which represents a gradient, is rise, or we look at the y-axis, over run, and we look at the x-axis. And there is a relationship between two things that are changing at the same time. And we know the gradient, what the gradient actually is, it's a constant rate of change. So constant rate of change. And it's important that you understand what this means. Constant means it's the same, it never changes. And rate of change, so something's changing, or two things are changing at the same time, and that it doesn't change, the rate is the same. Now, the gradient can actually be seen in a lot of the questions when you're given a problem. Sometimes it's not seen straight away and you have to also calculate it another way. But at this stage, all you have to do is identify the rate of change in the question, because the gradient is given to you in the question. So if you have a look at our problem, so a tank holding 600 liters of water, okay, empties. That's also important as well. Empties at a rate of, so a key word here that you can see where the gradient is, we've got rate of 200 liters, every is another key word. So that's sort of pointing where the gradient is given to you. So empties at a rate of 200 liters every hour, okay, or every 1 hour. And there it is, the gradient is right there. That's the rate of change, 200 liters every 1 hour. Now, to do this properly, we know that Y represents the amount of, represents water in liters, and X is hours. And that's why it's important to identify your variables, because when calculating our gradient, we have rise over run, or Y over X. So it's important that we know what is Y and what is X. So now all we have to do, there's Y over X. So the gradient will be, now let's have a look at the rate of change. 200 liters every 1 hour. So we know 200 liters, liters is water in a tank, so that's Y, and 1 hour is X. So it will be 200. That line, the vinculum, can mean every, in this case, 200 liters every 1 hour. And we have worked out our gradient. And we know 200 over 1, we'll just squeeze it down here, 200 over 1, the gradient is just going to be 200. But it's important to understand that there is a 1 underneath the 200, and in this problem, it means 1 hour. So every 200 liters, the tank is emptying. So every 1 hour, the tank empties 200 liters. And this vinculum here can mean every. It can represent a keyword which means every. So this fraction here is actually telling you a sentence. And it's a rate of change. It's the gradient. And in this case, the gradient is just 200. And now we have found nearly all of our information. Now, if I just stopped here, we would have made a mistake. The next step that we have to follow. So step 5 it's extremely important, and a lot of students forget this. Is the gradient positive? So is something increasing, or is the gradient negative? Is something decreasing? And that's how you can tell if the gradient will be negative or positive. If you're gaining something or increasing in value, then obviously that's positive. If you're losing, then that's going to be negative, and decreasing means losing. So if we have a look at our problem, here it is. What's a keyword that tells us we are losing? The gradient will be negative. It is emptying. So we're losing water from our tank. So the next step is to make sure, yes, we've got M is 200, but it is actually negative. So our next step is to put a negative there. If you wanted to, you can do that step first. Identify if the gradient is negative or positive first, and then calculate the gradient. Or you can do it this way. And there it is. Our gradient is negative because we're losing water. The tank is emptying. For every 1 hour, it loses 200 liters of water. And now we have everything we need for our equation. So now step 6, write the equation y equals mx plus c. All right, so we've calculated what c and m are. So we have y, which we know y is really the amount of water in the tank, is equal to y equals mx plus c. So we can write it like this, minus 200 x, and plus c. C is not 0, it is plus 600. And there's our equation. Now, if you wanted to, you can rearrange this and write your equation like this. And it's actually better to do it this way, especially when you need to use your equation to work out questions. So we've got y equals 600 first. So positive 600 minus 200x. All we have done is put the 600 first and then minus 200 times how many hours have passed. Okay, and there is our equation relating to this problem. Our gradient is negative, the minus in front of the x, and it's minus 200, or 200 over 1. Our initial amount c is 600. So now I've just added in an extra question. So 1a, we have done this already. Write an equation for this problem. We've done that. Now b says, using your equation, how much water will there be in the tank after 1.5 hours? So when it says to use your equation, you must use your equation and show some working out. Okay, so there's our equation here, and we know x represents hours. So if x is 1.5, all we have to do is substitute it into the equation. You can use your calculator to help you, and we're done. So y equals 600 minus 200 times, because we know we've got 200 times x, so times 1.5. And you can just chuck this into your calculator. 200 times 1.5. 200 times 1.5 would be 300. And 600 minus 300 is 300. Okay, and now that y equals 300, you have to explain what this means. Don't just stop there. So we can squeeze in here. You can use that symbol, therefore, and just write a quick sentence to explain what you have found. Therefore, there, we can say, will be 300. And what units are we using? Liters. So you put an L there. There will be 300 liters of water in the tank after 1.5 hours. And you can write that yourself. So please make sure when you have to answer questions like this that you show working out using your equation, but also write your final statement explaining what you have found. Now our next part to the question, I've just added it in, is what if the question asks you to draw the graph? We have our equation, We can use it to work out some problems if we have problems. But now, how do we draw the graph? Now, to do that, I've added in an extra step. And that is, once you have your equation, you can now draw an accurate table of values, which will help you draw a graph. Now you can see why it's so important that you state your variables. So you always have this in front of you, so you never forget what y is and what x is. Now we know a table of values, x is on top and then y is on the bottom. But I also want, you can put this in brackets because I want you to actually write what it is in relation to our problem. So y is water. Oops, sorry, that's x up there. So we'll start with x. X is time in hours. So I'll squeeze in hours. You can also write time. And y is water in the tank. And we know our units is liters. Okay? So always, when doing a table of values and you have an actual real life problem, write your variables, x and y, but also write what they represent. Now, sometimes the question will ask you to write a table of values. So you obviously include all of those values. Now, if they don't, it's up to you what or how many values you want to use. Now, don't forget that this is what confuses students. When we do a table of values for a straight line on a graph, if you remember, a table of values, when you're dealing with a straight line, it's a bit different to a real life problem. We have x and y, and what we usually do is in the middle, we put our 0, and we have some negative values, so -1 and -2, and then some positive values, 1, 2, and then we work out what the y values are, and we end up drawing our straight line on our graph. And we know we include negative values and positive values, so our line passes through more than one quadrant on our graph. So it passes through a few of the quadrants. But in this example here, when we have real life problems, we don't actually have to have negative values in the examples we will be doing. Because does it make sense to have -2 hours or -10 hours? It doesn't make sense. You can only have what? The smallest amount of hours you can have is, I guess, 0. So with problems like this, always start from 0, and then you can go by 1s, 2s, 4s, whatever you like, depending on what you're trying to do. But please make sure that you do have a pattern. That's extremely important, so we can see the pattern in the corresponding y values. So let's just go by ones. Always start from 0 and then go 1, 2, 3, and 4. You can have more if you wanted to, but 4 is enough. And the question hasn't asked us how many values to use. So we've just started from 0 and gone to 4. Now, to find the y values, we can actually use our equation. So if you remember, our equation was y, which represents the amount of water in the tank, equals, we had 600 first, our starting amount, minus 200x. If you don't like using this, and if you want to just use this one, y equals minus 200x plus 600, they're exactly the same thing, but you can use this one instead if that confuses you, because we rearranged it. But remember they're the same thing. Okay, so now all we're going to do is, remember, if x is 0, what is y? We know if 0 hours have passed, how much water is in the tank? There will be 600 litres. You can work that out without using your equation. But to use our equation, we say when x is 0, 0 hours, if x is 0 here, we will have this, y equals 600 minus 200 times 0 is just 0. So y will equal 600. So when x is 0, y is 600. And that makes perfect sense because we know the starting amount, when no time has passed, hours are 0, the amount of water in the tank, it's still full, so it's 600. Now, what about when 1 hour passes? If x is 1, we can do this mentally. We will have 200 times 1, which is 200, and 600 minus 200 is 400. Okay, and what is the pattern? We know that a table of values for a straight line, there's a constant pattern. Just like that constant rate of change, there has to be a pattern in the x values and also the y values. What's the gradient? To get from 600 to 400, we know we have to minus 200, and that's our gradient. And we know it's minus 200 over 1 because the pattern in the x, we know it's plus 1, so it would be 200 over 1. But we know this already. So all we have to do now is continue the pattern. What's 400 take away 200? 400 take away 200 is 200. What's 200 take away 200? Well, that's 0. And now, this might look confusing, but what is 0 take away 200? 0 take away 200 is going to be minus 200. And it's starting to look a bit confusing. So let's see what's actually happened. If we have 600 litres in the tank and 1 hour passes, so we lose 200 because we know we're losing 200 litres every hour. Another hour passes, we lose another 200. Another hour passes. See how we got 0 here? What does that mean? It's telling us there's 0 litres in the tank. The tank here has emptied. So at this point, we can basically stop because there's no more water in the tank. It does not make sense to have minus 200 litres of water in a tank. You can't have minus 200 litres of water. So in this case, we didn't even have to include that value there because it stops here. And now when drawing the graph, you don't have to use the 4 quadrants, okay? We're used to drawing a graph like this. You have the y-axis and the x-axis. You have the first quadrant, the second, the third, and the fourth. When it comes to real-life problems, and the ones you'll be doing this year, all you have to do is to draw the first quadrant. So the first quadrant means this. See the y-axis here, the origin, and the x-axis. So that's all you have to draw, y-axis and the x-axis. Forget about the other quadrants. We always start from 0, and then you can draw your graph. So we'll do a graph on another session, but see how you go. But remember, all you're going to do now is plot these points on your graph. When x is 0, what's y? Y is 600. So imagine you drew your scale and 600 was up here because y, remember, represents water. So if we have 600 litres in the tank, we know our gradient is negative. Our line will be going down and we're going to be losing water. And when we hit this point, okay, that is telling us there is no more water in the tank. So how we go, that was just to start you off, but we'll do a graph in another session. But hopefully that's been helpful. Thank you.